From the given figure, what is the area of the red circle? Hence, find the value of cosine x. Line constructions, Pythagoras' theorem, sine rule, cosine rule, and trigonometric identities are used to solve this question. Solution. Label points A, O, B and C. Area of the blue circle. A equals the product of pi and the square of r, where r is the radius of the blue larger circle. This implies that A equals 144 times pi. Make the square of r the subject of the formula. The square of r equals 144 times pi divided by pi, which equals to 144. Take the square root of the equation. R equals 12. Join line AC, which equals to 2 times r. The length of line AC equals the diameter of the blue larger circle. It follows that AC equals 2 times r, which equals to 2 times 12. The result equals 24 centimeters. Let us find the length of the square. Since line AC is the length of diagonal of the square, we will achieve this by using Pythagoras' theorem. Also, we will find the length of the line OA and line OB. Since line AB equals to line BC, it is because the side lengths of a square are equal. By Pythagoras' theorem, the square of line AC equals the sum of the square of line AB and the square of line BC, which equals to 2 times the square of line AB. Substitute values and we have that the square of 24 equals 2 times the square of line AB. It implies that the square of line AB equals half the square of 24. Take the square root of the equation. It follows that line AB equals the square root of half the square of 24, which equals to 12 times the square root of 2, after rationalization of the denominator. Hence, line AB equals 12 times the square root of 2. In centimeters. Let us find the angle which the line AC makes with the baseline AB. Also, we will locate the center of the red circle. Since line AC is the diagonal of the square, angle CAB equals to 45 degrees. This rule is for square. Locate center, G of the red circle. Join line OG. Let the small r be the radius of the red circle. This implies that line CG equals small r. Let us find the value of line AG and line OG. Recall that P is a tangent point. Hence, line AG equals line AC minus line CG. It follows that line AG equals 24 minus small r. Line OG equals the sum of r and small r, which equals the sum of 6 times the square root of 2 and small r. Also, line OA equals 6 times the square root of 2 in centimeters. It is because line OA is the radius of the semicircle. Let us find the value of small r from triangle AOG formed using cosine rule. Consider triangle AOC. Use cosine rule. The square of line OG equals the sum of the square of line AG and the square of line O minus 2 times the product of line AG and line O, multiplied by cosine 45 degrees. Substitute values of line OG, line AG and line O, A to form a quadratic equation in small r. We have that the square of the sum of 6 times the square root of 2 and small r equals the sum of the square of 24 minus small r and the square of 6 times the square root of 2. Minus 2 times the product of 24 minus small r and 6 times the square root of 2 times cosine 45 degrees. Expand brackets and combine like terms in one side of the equation. Simplify the quadratic equation that is formed. Let us answer the first question. That is required to find the area of the inscribed red circle. After simplification, we have that negative 36 times small r minus 12 times small r times the square root of 2 plus 288 equals to 0. Make small r the subject of the formula, so that small r equal the product of 24 and 3 minus the square root of 2, all divided by 7. In centimeters. We can now find the area of the red circle. Therefore, the area of the red circle, A equals the product of pi and the square of small r, which equals to the product of pi and the square of 24 times, in bracket, 3 minus the square root of 2, all divided by the square of 7. Simplify the result and we have that the required area, A of the inscribed red circle equals the product of 576 and 11 minus 6 times the square root of 2, all divided by 49, in square centimeters, or 29.56 square centimeters to 2 decimal places. This implies that line AG equals 24 minus r, which equals to the sum of 96 and 24 times the square root of 2, all divided by 7 in centimeters. After simplification of substitute values. Also, line OG equals the sum of 6 times the square root of 2 and small r, which equals to the sum of 72 and 18 times the square root of 2. All divided by 7. In centimeters. After simplification of substitute values. Angle AOG equals to 180 degrees minus x. It is because the sum of angles in a straight line equals 180 degrees. By sine rule. Line AG divided by sine 180 degrees minus x equals to line OG divided by sine 45 degrees. We will substitute already known values and use trigonometric identity to simplify the value of sine 180 degrees minus x. By substituting values, we have the equation shown on the screen. Cross-multiply, simplify, and solve for sine 180 degrees minus x. Hence, we have that sine 180 degrees minus x equals 2 times the square root of 2 divided by 3. Let us answer the second question. That is, required to find the value of cosine x. We will use trigonometric identity to solve for cosine x since we have obtained the value of sine 180 degrees minus x. By trigonometric identity, sine 180 degrees minus x equals sine x. Substitute the value of sine 180 degrees minus x we obtained. We have that sine x equals 2 times the square root of 2 divided by 3. We call it equation 1. Above. Also, by trigonometric identity, cosine x equals the square root of 1 minus the square of sine x. Substitute the value of sine 180 degrees minus x, that is, sine x from equation 1. This implies that cosine x equals the square root of 1 minus the square of 2 times the square root of 2 divided by the square of 3. Simplify this result. Therefore, cosine x equals 1 divided by 3.